Hello and Assalamualaikum everyone. Today we are going to continue with our lecture again. So we are going to enter subtopic 10.5.7 which is we have to find the solution of exact differential equation. So has some relation with subtopic 9.6.11. If we recall, if we want to know whether an exact equation for this subtopic, which is f x y, if this equation exists, therefore the differential df, so this is the f, equal to p x y dx plus q x y dy. And when we compare to the formula related to this, the previous formula that we have learned, we know that pxy is equal to delta f delta x, and qxy is equal to delta f delta y. Alright, so this is the formula that we have learned previously. So if f is exact, this condition should be fulfilled. Okay, but if there is we cannot find p xy q xy, therefore the equation is not exact. So in this topic, it is the form is quite similar. So in this topic, in this subtopic, so for the first order differential equation, we has the form of p, instead of xy we use tx dx dt plus q tx equal to 0. So if you aware, we have similar p right here and p right here, and we have q right here and q right here. So it is almost the same. The difference is we don't multiply in this equation everything with dt. If we multiply everything with dt, so we will have the same formula right here. Okay, almost like similar, but there's some a little different, of course, because this one is differential, and the one that we are learning right now is DE, differential equation. Okay, so this is the common form of first order differential equation, and from here we want to find the exact equation, which is h dx. So we want to find h dx. Okay, so let's say this is equation 1, right? So now we can recall a formula that we have learned, chain rule of differentiation. So we know that dh dt is equal to, so this is the h that we want to find. So this is the derivative of the h that we want to find. So this equation is equal to delta H delta X time delta dx dt plus delta H delta t. So you need to know the difference between delta and d. So delta is partial derivative and d is the ordinary derivative, right? So we state this one as, sorry, we let this one is the second equation, and then when we compare 1 and 2, we will have that delta H. So if you look at here, this equation and this equation, when we compare, we can see that there is similarity, which is dx dt. So now if we compare this equation, these two equations, we know that delta H delta x x equal to P T x, right? And then we also know that delta H delta T is equal to Q T x. All right. And then we can put these two equations inside 2. So what we will have is dH dt is equal to Ptx dx dt plus q dx. And we know that when we compare equation 1, this equation with equation 1 right here, we know that dH dt is equal to 0. Okay. So this is the solution for exact equation. And we know that from here, when we integrate it, we can find H is equal to, or Htx is equal to C. So this is the solution. Okay, to further understand again with this concept, we can try example 10.15. So again, we are given the equation 2x t dx dt plus x square minus 2t minus 2t equal to 0. Alright. So we make this equation equal to 1. Okay. So what do we want to find? What do we want to find in this problem is, again, similar. We want to find the exact equation H T x. So we can compare this equation with the formula. Formula 2. We can compare with this formula. Okay. So when we compare it, we can see that delta H delta x equal to 2xt and delta H delta t equal to x square minus 2t, right? So now we can try to integrate this to get h. Integrate this with respect to x and t respectively. So when we integrate this, h tx is equal to x square t plus c. Okay. And when we integrate another one, we can get h tx equal to x square t minus t plus c. Okay. Can you see the similarity between this equation and this equation? Actually, it should be similar. It should be similar if the equation, the exact equation, this one, is occur, is as this. If exact equation h tx exists, therefore we will get similar answer right here and right here. Okay, there is a little different. So this one should not be the same c, this is c1 and this c2. Okay, when we see this kind of answer, we can assume this one is more accurate, and we can try ourselves whether this is accurate or not. And we can also simplify by eliminating the constant right there. So you can try by yourself whether this equation is correct or not. So x square t minus t. So when we integrate in with respect to t, delta h delta t is equal to